Good morning, students. Today class we are going to study about quantum number. What is this quantum number? Means quantum numbers. The quantum number is nothing but a set of number used to describe the position of electron and energy of electrons. You see, we know that this is the atom, it's a nucleus, the electrons revolving, means a quantum number is nothing but a set of numbers, means electrons, numbers we are talking that electrons means in orbital which positions are there, and energy of electrons means what we are going to study. Set of numbers used to describe the position and energy of the electron in an atom is called quantum number. Okay, there are four types of quantum numbers. Mainly there are four types. Number one, first is principal quantum number is denoted as small n. Second one is azimuthal quantum number, it is denoted as small l. Next is magnetic quantum number, it is denoted as m l also. Some books will tell m, some another NCERT books tell ml. Another last quantum number, that is spin quantum number, it is denoted as ms. These are four quantum numbers. First, I already told what is quantum number, a set of numbers used to describe the position of the energy of the electron in an atom is called quantum number. In that, first we are going to study about principal quantum number. First we are going to study about principal quantum number, is denoted as small n. Okay, what it will explains the means, you see it first of all, principal quantum number will explain the in atom means energy of the electrons. First, the principal quantum number, it explains the energy of electrons in the orbitals. Okay, energy, and also it explains first point what I told, energy associated with electrons, energy associated with the electrons. Next, the second point, you see average distance means the distance of the orbit nucleus to electrons, means it also explains the average distance of electron from nucleus. Second point is over. It explains only the main shell present in the electrons, means main shell in this orbital, means K shell, L shell, M, another one is N. Okay, it explains the main shells. It explains the main shell in which electrons is present. That is K, L, M, N, so on. Means you see in principal quantum number, very important, that is N, small n will start from 1 to so on, but never from 0. Please, you want to remember, in principal quantum number n will be starts from 1, never from 0. When we talk about energy of orbitals, they given the formula. It's very important in the principal formula. We have already solved some problems. Previous video I solved the problems. That is energy of nth orbitals. Energy of nth orbital, En is equals to minus k square 2 pi square m to the power of 4 divided by n square h square. It is, we can write that En is equals to minus 2.18 into 10 to the power of minus 18 by n square units joules. This is the principal quantum number. In principal quantum number, we study the energy associated with the electrons, means energy of the electrons to be explained, and average distance from electrons from nucleus, and it explains the main shell of the electrons present in K, L, M, N. It explains like that. That main shells are, it is K, L, M, N, and N means principal quantum number starts from 1, never from the 0. Energy of nth orbital is nothing but, they give the formula, En is equals to minus k square 2 pi square m e to the power of 4 by n square by s square. Okay, next we are going to study about azimuthal quantum number. Azimuthal quantum number. Okay, azimuthal quantum number. You see, in this the previous principle I told that it explains the main shell, but in this azimuthal quantum number, it gives the information about subshells. Means you see, again I want to write this atom. K, L, M, N. In K, S, P, D, F orbital subshells. Okay, means it explains or gives information about presence of electron in subshells, that is S, P, D, F, and also the azimuthal gives the shape of the orbitals, that is dumbbell shape, spherical shape, like this we'll talk. Now the azimuthal quantum number is denoted as small l. Already I told that small l will starts from 0 to n minus 1. For example, if you take a principal quantum number n and l, if n is equals to 1, l formula n minus 1. 1 means it's 0. If n is equals to 2, it will become 1. N is equals to 3. L value is nothing but 2. This is the azimuthal quantum number. Next we are going to study about magnetical quantum number. Magnetical quantum number, it is denoted as ml. Means in magnetical, what it tells, it will be orientations. Means the orbitals, means atomic orbitals moves in orientation d. It moves in orientation d. It moves in orientation d. You see, for example, if you take magnetical quantum number moves orientation of atomic orbitals. It has the formula ml is equals to 2l plus 1. 2l plus 1. If you talk, now we are going to do substitute if n, l, m, ml. Okay. If n is equals to 1, if n is equals to 1, we know the formula L is equals to n minus 1. Correct? No. Then it becomes 1 minus 1 becomes 0. Correct? No. If we substitute 0 in ml, we have the formula 2l plus 1. Correct? No. If we substitute 2 into L is nothing but 0, 0 plus 1, it becomes 1. 1 means we know this 1 electrons is nothing but S. Correct? No? Electrons. If we talk n is equals to 2, n is equals to 2, then what will happen? 2 minus 1 became 1. Became 1. Correct? No? But already I told you L starts from 0. L starts from 0. L starts from 0. For that we will take L is equals to 1. For that we take 0, 1. You understand here? Okay. Then we are going to write first what is the L value? L value is nothing but 1. 2 into 1 plus 1. Correct? No? 2 plus 1, 3. 3 means it starts, you see, this magnetical quantum number will have 0, right hand side must be minus, left hand side plus. Okay, this is main important while doing. You see, 3 numbers must become, for that what we write? 0. Correct? No? We start from 0 only. 0 minus 1 plus 1. It become 3. Correct? No? See, it become 3. 3 means it is P. Then we can write it is a Px, Py, Pz. Correct? No? Next, while we are going to see another one. If n is equals to 3, n is equals to 3. What happened? If n is equals to 3, then L is equals to 3 minus 1. Correct? No? Is equals to 2. Then it starts from 0, 0, 1, 2. Correct? No? We got ml formula is n minus 1. It is 2l plus 1. Correct? No? 2 into 2 plus 1, it becomes 5. 5 means 0 minus 1 minus 2 plus 1 plus 2. See, it is 5. 5 numbers are there. It become 5. It represents, it is a d orbitals. D orbitals. D orbitals means you see 5. dxy, dyz, dzx, dx square, y square, dz square. Next, last quantum number, that is spin quantum number. Spin quantum number. You see, spin quantum number is denoted as ms. Spin quantum number is nothing but if you take the atom, and you take a clock, for example, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You see, if it moves in clockwise direction, it is clockwise direction, clockwise, then it is plus off. If it moves in anti-clockwise, it is minus off. Anti-clockwise. Then ms will represent spinning of the atoms. Ms will represent that spinning of the atom, maybe plus or minus of. Okay. Next I will write this in one tableau column. One tableau column, very very important, that is tableau column. That is will represent that possible. Okay. First we will write I'm going to write, you see, first energy n, possible value of L, then another one is designation of subshell, and possible value of ml. Okay, first we take energy, that is K. If you take K, n is equals to 1. What is the L value? 1 minus 1, correct? No, it is n minus 1 formula. 1 minus 1, then what happens? It will become 0. If 0 means yes, n is nothing but 1, correct? No, n is nothing but 1, s is nothing but 0. Okay, do you understanding here? Next, you see possible value of ml. ml is nothing but formula 2l plus 1, correct? No, if l is equals to 0, then what happens? 2 into 0 plus 1, correct? No, 0. Okay. Next we are going to talk about energy. Another one is, it is L. N is equals to 2, correct? No, n is equals to 2. 2 minus 1 is equals to 1, correct? No, while we already told that it must start from 0 to n minus 1, correct? No, then 0 1 0 indicates that it is s, correct? No, n is nothing but 2. 1 indicates that p, then 2p. Do you understand here? Very very important. 2p. Now while going to ml, what we will write? L is equals to first 0, no? 2 into 0 plus 1 is equals to 0. One thing. Sorry, it is 1. Sorry. 0 plus 1, no? 1. And the one, 2 into 1 plus 1 is equals to 3. We can represent 0, minus 1, plus 1. Correct, no? Next, we are going to talk about m. M means it become 3 minus 1 is equals to 2. It must be start from 0 1 2. C, already explained, it is 3s 3p 3d. You understand why I am writing this? How can I write this? 0 1 2. L value is nothing but 0, then it is s orbital. L value is nothing but 1, it is p orbital. Okay. Now I am going to write the possibility ml means how much it is there. You see, we got a 2. L is equals to 2. No, 2 means sorry, I will write a line. You will be maybe confused. Okay. You see, 2 into 2 plus 1 is equals to 5. We can write 0 minus 1 minus 2 plus 1 plus 2. We can represent. Next last is nothing but n is equals to 4. 4 means 1, right? 4 minus 1 is equals to 3. Must be start from 0, 0, 1, 2, 3. Correct? No. It represents 4s, 4p, 4d, 4f. 0 represents L is equals to 0, then it is S. L is equals to 1, it will be P. L is equals to 2, D. L is equals to 3, F. Okay. We know L is equals to 3, no? 2 into 3 plus 1, it becomes 7. 0, minus 1, minus 2, minus 3, plus 1, plus 2, plus 3. Okay. You understanding here? Okay. Now I will write what is this explains. You see L before. You see, if L is equals to, okay, then orbitals. Which orbitals? I will tell that. If L is equals to 0, then it is S. 1, P, 2, D, 3, F. This is very important. You see, you understand. If you not understand me, you can comment me. If I want to explain, 1 second, I will surely explain this. Okay. Next, we are going to solve the problems. We are going to talk about problems. Problems based on quantum numbers. Okay. First, energy. It's not a problem. It's a very important formula. Energy of the electron in hydrogen atom is given. Energy of electron in hydrogen atom is given by the expression that is En is equals to minus 1.312 into 10 to the power of 6 joules per mole divided by n square. Okay, now we are going to solve the problem. You see this problem, first problem we are going to study. Calculate the amount of energy required to promote electrons from first energy level to third energy level. What they are telling, calculating the amount of, means we want to calculate the amount of energy required to promote electrons from first energy level to third energy. Means how much energy must be required for first energy to third energy. Okay, first we want to divide. First we will write that first energy level. We know formula. En is equals to minus 1.312 into 10 to the power of 6. First energy, for that we will take 1 square joule per whole unit. The En is equals to minus 1.312 into 10 to the power of 6 joule per mole. Next we want to find out, they ask me third, correct? No, third energy level, that is En is equals to minus 1.312 into 10 to the power of 6 divided by 3 square, because the third energy level 3 square joule per mole. If we calculate, we will get minus 1.408 into 10 to the power of 5 joules per mole. we got E. We can write this is E1. You can understand easily. E1. This is E3. Now we are going to calculate change. How much the change between these two? Okay, for that the energy change is equals to E3 minus E1. We'll get minus 1.408 into 10 to the power of 5 minus 1.312 into 10 to the power of 6. Correct? No. Minus plus it becomes, okay, the overall plus 11.66 into 10 to the power of 5 joules per mole. The energy required to promote the electrons from first orbital means you see the first orbital means first orbital to third orbital. You see, first 1 2 3 first orbital to third orbital, this much of energy must be required to promote the electrons from first to third. It is plus 11.66 10 to the power of 5 joules per mole. Okay, next I am going to talk another problem. That is what will be the ionization energy of the hydrogen? What will be the ionization energy of the hydrogen? Okay. What will be the ionization energy of hydrogen? First of all, what is ionization energy? What will be the ionization energy of the hydrogen? What is the ionization energy? Ionization energy is nothing but the amount of, okay, I will write like this, ionization energy in short form. Ionization energy, amount of energy required to remove the electrons from outermost shell. Means ionization energy, it is outermost shell, means we don't know they are not telling that how much the outermost energy. Okay, if you take the energy, first of all, energy is nothing but first ground state will be E1. It is outermost. They are telling what will be the ionization energy of hydrogen. Ionization energy means removing the electrons from outermost. Outermost maybe it is infinity. It is infinity. The ionization energy are infinity minus E1, or else why we want to confuse, we can make a delta E only. Delta E infinity is equal to 0 minus 1.312 into 10 to the power of 6 joule per mole divided by n square. Correct? No, n square is nothing but 1 will get delta E is equals to my 1.312 into 10 to the power of 6 joule per mole. Okay, next we are going to study about